So we're going to look at rotations in a couple of ways. As you see from this page, we're going to do a rotation around a point. We're also going to do rotations on graphs around the origin and around other points. So a bunch of things with it like that. Okay. We're going to draw a 50-degree rotation, and I'll model this and show you and the best way to look at doing it. Okay. We are going to take this and move this 50 degrees. So we are going to line it up. In fact, to make things easier, put an actual dot at the point. That will make it easier to use. Put dots at each one of those points. So the way you use this is you take that little middle point and you put that on the point. So I said point P, that means this is point P here. I'm going to put that on point, and I'm going to line it up, get it so you can see without the glare. I'm going to line it up here. I need to name that. So this will also be easier when I'm talking about it. So let's call this one A, I'm going to call this one B, and I'm going to call this one C. So we're going to move it so that it's 50 degrees turned. So back here, and you see how I line it up with that line between the two measuring places. From here, the point through A is at 0. Because you see how it's coming 40, 30, 20, 10, 0. 160, 170, that's 180 if I was starting here and coming around this way. So we're going to start with this one. Because it's 0, 10, 20, you can tell from the spacing. And that spacing is what helps you that if this is at 0, then the new A is going to be at 50. So you're going to come to here. That means that A is going to be along this line. So this A is at 0, but the new A is going to be at a 50 degrees. So I need to come up here. And what I do is I put a little dot way out there. At 130 and 50 match because they add up to 180. So put a little dot out there. You could put one in here, but it starts getting sort of messy on the inside part. So try to put it on the outside, and then remove it. So we got this little dot here, which is a 50-degree turn, but we need to put A on that line, that invisible line there. You do that by measuring the distance here. I set this up pretty well. It's just about 2 centimeters. Now, I like to use the millimeters and centimeters just because it gets you a little bit more precise. If you like to do the inches, that's perfectly fine. You'll just have to set up make sure you're comfortable with which dashes. But I'm going to stick with this because I think it's easier. So it's almost exactly 2 centimeters. Once I've determined that, I'm now going to come over to that invisible line, that A line, and set it up and go to where 2 centimeters is. I'm going to put a dot there, and that's my new A. That means I need to call it A prime. Now I can ignore this. If I was using pencil, I would now erase that. Okay? Just because I don't need that one anymore, I have this one already at 50 degrees. What I just did by measuring where 50 is for the A, then measuring the distance, then remeasuring the distance on the other line, we're going to repeat that for B and repeat that for C. We're going to do the same thing. The difference is that B's 50 is going to be somewhere around here, and C's 50 will be somewhere around here. So I'll repeat it, and you can follow along. I'm going to first put point B in the middle and line it up with B exactly. And then I'm going to see where 50 is. I'm going to go way off up on the page to put a dot there. That's the first step, is to see where the invisible line is towards 50 degrees for the B. Second is I'm going to measure from 0 out to where the B is. And that looks like about 47, 48, maybe 47 millimeters. When you do things like this by hand, you can't be completely precise. So I say it looks like 47, and someone else could say it looks like 48, and someone else could say, now that's 46 or 49. You're close enough. Okay? Reasonable. If you looked at this and said it was 21, then we got a problem. But if you're reasonably in the same area, you're in good shape. Now I'm going to go from point P out to here, because that's 50 degrees, the 50-degree line. And I'm going to go up to about that 47 that I thought it was. Maybe 48, I think I marked it at 48. So this is going to be where B is. I can, even if I feel like it, draw the line between these right now. I don't have to, but I can. This line is this line. So this line just rotated 50 degrees. So it just went like that because it's a 15-degree turn. Now we need to put C in so we can draw the other lines. So we're going to do the same thing. One, measure for 0 degrees from point P to where C is. That's 0 degrees. As precise as possible, knowing there's a little leeway. And then here is 50, and so I'm going to go to the far outside part for that one, right above the H in the writing. And then I'm going to measure. Measure once and measure twice. That's just under 65. That looks like 63. So it looks like 63 millimeters. So I'm going to go up here, this one to that new point I put, to where 63 would be, right about there. And that's C. And now that I have A, B, and C, I'm going to draw the lines. So that looks right. I'm holding it like this, A, B, C, and they look like they're the same shape. And if I rotate that to about where it was, yeah, that looks about right. That's there. I rotated. It looks like it's about the same one. So I feel pretty good about this one. If I was doing it in pencil, I'd erase these 3 little points now. But they're the only actual indicators that you use something. Now it looks right. When you do this for me on the test, I know where it's supposed to be, so if you're reasonably close, like really pretty close, then you're in good shape. Like if it's about that, but say it was down about here and up about there and a little bit about there, that's good. But if it was like here, something's wrong. So I can pretty much tell at a glance that you're reasonably close or you're not even anywhere near it. So you should be reasonably close. Now down here, we're going to do the same thing. I want you to start this. Actually, I'll help you with the first one, and then I want you to do the other ones yourself. If you already feel good about it, do them all yourself right now. But I'm going to do A. Whoops, oh, I put that B, so it doesn't matter. I'll call this one A then. So I'm going to do, now, there is something else I forgot to say. Draw a 50-degree rotation, and notice I went counterclockwise. Down here on this one, it says go clockwise, this way. But it didn't tell me up here. There is a little one line in your book, actually it's a paragraph of like a line and a half or so, that tells you that if it doesn't say, then the default is to go counterclockwise. So I purposely didn't say it on here and then forgot to tell you, but now I'm remembering. That if it doesn't tell you to go clockwise or counterclockwise, then automatically you're supposed to go counterclockwise. So remember that you always go that direction unless you're told different. This one tells you to go clockwise, so instead of moving it this way, we're going to move it this way. That changes a little bit about how you'll use this. So I am going to call this P anyway. I'm going to line it up with A, and this time now I'm having to use it going up like that instead of sideways. That's just because of where A is. And I'm going to look for 140 degrees. So now we're on the outside one because we've got 0 here and all the way out to 140, which, let's see, you can see it now. All the way down to 140, and I'll put a little dot there. So that's my dot for A. So I'm going to put my A somewhere along here. The distance from here to A is the distance I need to go here. So we'll measure. I love the fact that this one has a measuring part of it. Don't need other tools. So it doesn't matter if you go from P to A or A to P because the distance is the same. So this looks like 45, 46 millimeters. So I'm going to do that here, and it looks like that's 46 millimeters here. That's A. Oh, A prime. I forgot to put prime on these ones, B and C. So I'm trying to remember. So that's where A is. I'm going to do the other two, but I want you to do them first. If you haven't already done the other two while you've been sitting there working, then do them now, please. Figure out where B is supposed to be and C is supposed to be. And then I'll show it too, but I want you to practice, get a chance to practice doing it. Some of you might have done C before B, that's perfectly fine, but I'm going to show it as I go along. I'm going to show you B first and then C. So here I've set it up so I can do the 140, and that's what you hopefully did. That looks like 48. If you got it done, it should look a little bit like this. I'm not sure, my measurement from P to C here looks a little smaller than my measurement from P to C here, but I think it's pretty close. So it should have, and I did these little lines to show, it's sort of like taking it and swinging it around to here. So that line swung around to here, that one swung around to here, that one swung around to see. Oh, wherever they each go. Okay. So it looks like the distances are the same, to A and A and to C and to C. And it looks like if this one flipped around here, that line would match that one would match this one, because it almost looks like a right angle here to this one and this one. And then almost looks like hypotenuse to the other one. Okay. It takes a little bit of work, but if you are comfortable with this, and think about those 3 steps, all right, so where you measure 140 degrees, and then measure P to whatever line, and then measure, or to whatever vertex point to new point. So it's really 3 steps. Okay, any questions about doing this? Now we're going to look at it on the next page where it's a graph. Rotate 90 degrees around the origin. Now, these first two, 90 degrees and 270 degrees, aren't going to be that bad. The next ones will take some work. In fact, where's my third? Yeah. Oh, this one won't be bad either, this 90 degrees. 150 though, but it's around the point. This one will be bad. In fact, when you do this one, there's a couple of ways to do it. You might even want to use the protractor again. This one you'll almost certainly have to use a protractor for. Okay, but I'll show you as we get to that. Rotate 90 degrees around the origin. Right, so let's put these points on. 3 and 1 for A. 7, 4, 5, 6, 7, and 2 for B. And 4 and 5 for C. That little triangle now is going to rotate around the origin. It doesn't say which way, so that means we're going counterclockwise. That means it'll go this way. There's an easy way, semi-easy way, and a hard way. And the hard way is not all that hard, but still. The hard way first is you can use this and you can do 90 degrees. So I can do 90 degrees, and then I can measure that distance and go that distance. Okay? The other thing I can do is that because I know this is rotating to here, 90 degrees means I'm going to go down 1 and over 3. So I'm actually going to go the opposite. Down 1 and over 3, I'm going to go sideways 1 and up 3. That's where the new A should be. Another way to do it, so I'm going to actually put that there. Another way to do it is that a 90-degree rotation means it moves 90 degrees. So if you do this visually, if you're not doing this on a computer, even as I guess you can tilt your head. But if you're doing this on a piece of paper, just turn the paper. Turn it 90 degrees. That means that if this was the new coordinates and this was the y-axis, the x-axis, A would be at -1 and 3. -1 and 3. So that's A prime, and that's going to be at that point. Now I'm going to do it with B. If I turn it, I see that that should be at -2 and +7. So I'm going to come back. I'm going to go -2 and 3, 4, 5, 6, 7. B prime. I'm going to put the points with it too. -1 and 3 for that one. Because you'll notice a little sort of pattern here. Oh, that's 7 and 2. And this one was 4 and 5. So now I'm going to look at the C. Turn it. C is at -5 and 4. 3, 4, 5, and 4. C prime. So this just got rotated there, so it looks like that. So if you have a piece of paper, use that. Rotate it. If you don't have a piece of paper, you're going to have to recognize that for this one to go over there, think of this as the y-axis, and then mentally say, well, if this was moved over to here, that point would be here. You could also measure it with a protractor and see that this is a 90-degree angle. And that is, you don't even really have to use a protractor like that. You can go like this and go up that way and then realize, okay, I should go down 1 and over 3. That means I should go over 1 and up 3 to get to this point. And I could do the same thing here. 2 and 7 means going 2 and then 7. Okay, and 5 and 4 means going 5 and 4, but you end up with -5 before there. -5 down. So those are a couple of ways to do it. Okay, so think about what happens when you rotate it like that. And now let's take a look at the bottom one. So let's first put this point in, this triangle. 1, 2, 3, 4, 5, 6, 7, -7 and -2. So that's A. B is at -3 and 1. -1. C is at -3 and -5. 3, 4, 5. So we're going to rotate it 270 degrees clockwise around the origin. So clockwise means we'll go 1, 2, 3 times around. Oh, wait, that's 2. We're here 1, we're going to there, going there, and we're going to come down to here. Okay, that's what it should look like in the fourth quadrant. So you can do that to make it easier. If you're going around this way, isn't that the same as going 90 degrees that way? Let's take advantage of that. I mean, and I could show you going around 270, but frankly, you should take advantage of it, so that's the way I'm going to go. So I'm going to take this one, and I'm going to go 90 degrees that way, and it's the same thing as going the other way is 270. And so that means it's like going up 1/3, and then it gets confusing. So if I go like this, I can see that the B is supposed to be at -1. No, +1. +1 and -3. So now I'm going to come back and go +1 and -3. That'll be B prime. And then the C, actually A, I guess I'll do A. So I'm going to go this way. A is at 1, 2, and 1, 2, 3, 4, 5, 6, 7. So 2 and 7. 3, 4, 5, 6, 7. That's A prime, 2 and -7. Now I'm going to do the same thing with the C, but I already know, you remember, this is a vertical line and it's 4 down from the B. That means this is going to be a horizontal line going over 4. And in fact, I'll verify it now by going like that. Yep, that's exactly where C should be, or C prime. And that's at 1, 2, 3, 4, 5, 5 and -3. So this one rotated that way to become that one. Now, you will see on the internet, and sometimes in the textbooks too, where it'll tell you, oh, if you're going a 90-degree turn, just notice that you switch the numbers and change one of the signs. Feel free, you're welcome to memorize that, but frankly, I think because it's different for the 90s, which way you go, it's different for 180, it's different for 270, because it's part of the 90. I'm not interested in trying to memorize like 3 different rules that all have variations. Instead, what makes sense? Think about what makes sense of, if this is going to go over to this side, I can go up and down or over and up, but I can also rotate it visually like this or in my head. All right. Let's take a look at the third one, page 3. So the first thing, please put these points, 3, 1 for A, 7, 2 for B, and 4, 5 for C. This is the one that says page 3, 14-6, page 3. And then put a point at 3 and -2. I'll let you catch up getting that in there. Now, if this was around the origin, it would be real easy. I just go 90 degrees like that. But it's not around the origin. If I take this one and do that, it's a little bit confusing about where that is because the axes aren't in the same places. So this one's a little more difficult to do. So I like the idea of moving the page. So I sort of want to do that. What I'm going to do is I'm going to pretend that these lines do not exist. I am going to make a new axis at x equals 3 for the y-axis, and a new axis going this way. So this would be the x-axis, and that's at y at -2. So I'm going to try in my head to just ignore these other lines. And I'm going to pretend that that's the origin, and now if I move it, like that. That means on the new horizontal line, the A needs to be 3 spaces over. When I come back here, on the new horizontal line, I need to go 1, 2, 3 spaces over. So that's going to become A prime here. So that one went to here, and that one does now, if you think about it, that one does make sense. Remember, we're doing a 90-degree turn. It's counterclockwise because it doesn't say anything. And if I go down this way 3 and over that way 3, when you're going vertical and then horizontal, you know that's 90 degrees. So we know this one is a 90-degree change. That helps because having one of them that matches on is great. If it wasn't, well, we can still do it. In fact, now with the C, we'll think about that. In fact, think about what this helps now. C is 1 away from this line. When we turn it, C is 1 away still, but now the line is going horizontal. And C is 1, 2, 3, 4, 5, 6, 7 spaces down from here. So if I turn it here, I need to be 7 this way and 1 up. So when I come back, I need to go 7 and 1. That would be C prime. So think about how I thought about it. When I look at this, I see I'm going 7 and 1. When I turn like this and I see, oh, that makes sense that it should be 7 and 1. So when I come back here, now I use that 7 and 1. It's just a negative 7 and a plus 1. But if you're going the right direction, writing it down, doesn't matter what you call it. So now I have C prime in the right place. So this line is over to here. Now we're going to do with B. And B, it looks like it's 4 this way and 4, so both 4s. So if I turn it here, it looks like I need to go over 4 and up 4. Okay, so I'm going to come back, and I'm going to go 1, 2, 3, 4. 1, 2, 3, 4. Okay. And I'm uncertain about that, so I'm going to do, if this would be a lot better with pencil, but I'm going to do like this, and I'm going to say, okay, if I do these lines, that look like 90 degrees. If I were to measure it, yeah, that goes up to where the 90 is, so it looks like that's a 90-degree angle. Okay, and the next thing is, are the distances actually the same? Or close to the same? 0 to, that's about 22. And 0, that's about 21, so it looks like my drawing, or my not putting the dot a little further out to check that. And now I can tell that's pretty close. 21, 22 millimeters, that's close enough when you do that by hand. So this one rotated to here. A to C rotated down to here, B to C rotated to here, and A to B rotated to here. It just rotated around this line. So like that one went to here, that one went to here, that one went to here. Like this one moved over to become this one. You don't have to fill these in, I'm just trying to make sure it's easier to see. Okay, one last one now where we pretty much will have to use the calculator, because you notice when it's 90 degrees, you can just turn it like that. 180 or 270, those are all easy. This one's not. So on this one now, we're going to have to use the protractor. So sometimes that's needed. Let's put the point, -1, -3, and then let's put all of these on here. So that's this P. We're going to go to -7 and -2 for A, -3 and -1 for B, -3 and -5, 2, 3, 4, and -5 for C. And we're going to rotate 150 degrees clockwise. I'm going to wait till you all have this drawn on here before we do it. Well, we're pretty much stuck that we can't just move the paper like with 90 degrees, so we're going to need to actually measure it. At least if we're going to get it right. So I am going to line up as if it wasn't on a graph at all. So in a way, this becomes sort of just like the other first two problems we started with in this one. So if I line up P and A, and then I look for 150 degrees, that's way over here. I might even have to go on the inside for it to make that easier. So clockwise all the way over to the 150. Now I'm going to measure this. 0, that looks like about 23 or 24. And I'm going to go on this one about 23 or 24. 23 or 24. Okay. Now, that is not on an intersection point, it's in the middle. That's perfectly okay. When you're doing a 90 degree or 180 or 270, you should be at a point, because it should be an intersection point matching what the other ones are. But here, when you're going like partially in between, it's not that way. You know, that's not a 90 degree turn, so it could be like, it couldn't be on, might not be on that point, it might be a little further along. So that means it's right about there, a little bit big, I do that. But now I'm going to do the same thing for B, which is not very much of a distance it's going to go. But I have to line these up and then go to 150. And then measure 0, that's almost exactly just 1. Okay. So that's B. Oh, I forgot to put A prime and B prime. So I would have to lower my grade if I didn't put that. Now we're going to do the same thing with C. I'm going to line this up. Oh, I'm doing C. I need to go to P to C. Good. Got that right. Here's about where 150 is. I'm going to check something. I did a mistake. Let's do C first before I draw any more lines with you. Let's do C first. I'll go through my mistake because it's an easy one to do. I've done it before, so I did it this time again. P to C. P to C, and if that's P to C here, then 150 looks like it's about here. Now the measure. That's about 13 or 14. I made that dot a little too big. So now I'll do 13 or 14. That's where C will be, C prime. But I think the B is a little off, and let me tell you why I know. Okay? So when I measured for A here, I lined up the center with the point and then went to A, and then did 150 degrees over to here. Okay? Got that off a little on it. Yep, so I lined it up. There was my A line. And I just did the C one out to here. But the B one, I went down to here. And here's why. This is an easy mistake to make, so I'm glad right now I did it to show you. But if I line up this, if I line up P to B, P is in the center. What I actually did is I went to B and I did it with B. So I lined up B to P, and I think I put my 150 about there. So I'm going to really double check and make sure if I did this right or wrong, and let's do it right again. From P to B, and that's where 0 is. Okay. P to B, and it looks like maybe I'm okay. No, I don't think so. Okay. 0 to 150 should be about here. And then I measure. Okay, I may have been right. Okay. I second guess myself, and you should do that too, because notice the mistake I thought I'd made, and I just double checked and I didn't make it, is that like from here to C, I sometimes put the center here and I'm doing this measurement there and I'm going the wrong way. Just be careful of that. I didn't do it, but I thought I did, so now I'm sort of glad I didn't, but it's something that's easy to do when you use these, so be careful of that kind of thing. So in this section, you have to be able to use a protractor to rotate around the point when you're not on a graph. Rotate on a graph using the origin, and rotate when you're not at the origin, and if it's an amount that's not a 90 degree or 180 or 270, then you might need to use, or would need to use, a protractor for it. Okay. Like I said, you are welcome to borrow a protractor if you wish to.